Please do it, then we will continue.
Okay.
Write the UPSC name of following. Are you able to see the screen clearly, right? Let me know if there is any problem in
No problem.
reading. Okay, in this chapter, one more thing is important. That is your, you need to go through the, what do we say? You need to go through the common name as well. Okay, catechal and all. That is very
Okay.
important. Please do this. Wait a minute, please. So Humam and Austin. I'm going to explain this. Very simple it is. Today we are going to cover this part as well. Just wait a minute. Humam, are you done with this?
Okay.
Yes or no? I'm not able to hear.
Oh, no.
Okay, so now I'm going to explain this. You can see that the first one, this is your functional group. This is your functional group. So we are going to do numbering from there. 1, 2, 3, 4, 5. There is no substituent. Jump to the parent chain. How many carbon? 5. So pent. Then nature of bond, that is 3 in. And then 2 all. Is this correct, Humam?
Yes, sir.
Now, for the next one, if you are going to see, this is your functional group, right? This is your functional group. So everything will be on the basis of this. So what we are going to do, 1, 2, 3, 4, 5, 6. And there is a substituent. If you are going to look at this closely, this is your substituent. We write the name of substituent first. We write the name of substituent first. So I'm going to write the name of this substituent, that is 4-fluoro. Then jump to the parent chain, 6 parent chain carbon. So hex 4 in and then 2 all. Is that clear? Alcohols, phenols, and ethers, right? Topic. Ethers. Okay. The next one is your parent chain is what? This cyclic structure. This cyclic structure is your parent chain. So what I'm going to do, numbering from here. There is no branch, so directly jump to the parent chain. That is your cyclobute. That is your cyclobute. And you can see on the first carbon there is in. So 1 in, 1 on. So you can write cyclobutanol as well. You can write cyclobutanol. That means on the first carbon all is there, or on the first carbon OH is also there. Okay. For this, the second one, if you are going to look at this carefully, this is your alcohol, that is your main branch. So we are going to number it from here, 1, 2, 3. This is your branch. Which one is your branch? This is your branch. So we can easily name it. You can see, if you are going to name it substituent, that means 3-nitro, or you can use M-nitro as well. At the place of nitro, you can use M-nitro, and this is your phenol. So you can directly write phenol. Phenol. This is your phenol. For this, 1, 2, 3, 4, 5, 6. So this we can write 2, 4, 6 trinitrophenol. Trinitrophenol. In the last one, if you are going to see, there are 2 functional group. One is your aldehyde and another is your functional alcohol. Aldehyde is seen here, so we are going to give preference to this aldehyde, 1, 2, 3, and then 4. And now this will be used as substituent. So name will be 3-hydroxy. When alcohol is used as a substituent, its name is hydroxy. Then bute, and at the second carbon you have ene, and at the first carbon you have al. So you can directly write 3-hydroxy bute 2 in null. So I think it's clear to both of you. There is no problem in this question. If there is any doubt, you can ask me. So today we will be focusing on the preparation, and in this chapter you will come to know about the mechanism of some compounds, which is very important. Are you done with this?
Yes, sir.
Okay, let's start the new topic. That is your preparation of alcohols. So phenol is also there, but we are going to first prepare alcohol. Preparation of alcohols. So it's very easy basically. If you know the previous reactions, you can do this easily. So the first is from alkenes. From alkenes. Now, from alkenes, how do we prepare this? So let's see. From alkenes, there are two methods, in which the first one we have is by acid catalyzed hydration. By acid catalyzed hydration. Hydration basically, you are going to add water molecule to an alkene and you will be getting an alcohol. How does this takes place? So with the help of an example, I'm going to show you. This is your C double bond C, in which you are going to add water in the presence of acid, which will be acting as a catalyst. So what will happen? Basically, this bond will be broken. And since it is an asymmetrical alkenes, it is a symmetrical alkene. Symmetrical, not unsymmetrical. It is symmetrical. You can add anywhere. Water has two parts, H plus and OH minus. So you can either add H plus here or OH minus here. It won't affect. So H is there and then it becomes OH here. It will be like this. For an example, if we are going to take propene, which is this unsymmetrical. I took an example of unsymmetrical alkene. So you can see what will happen. This bond will be broken. Water has two parts, H plus and OH minus. So where does this OH minus go? So this will go to secondary and this will come to the here. So what you will get, you will be getting basically CH3, CH2. The double bond will be converted into single bond and this will be the product. So basically it is somehow following your Markovnikov. Markovnikov, if you remember, what does Markovnikov says? Negative part will go to that carbon which has lesser number of hydrogen. In the first chapter we did. And positive part go to that carbon which has greater number of hydrogen. And I think it's clear to both of you. Yes or no? we will do the mechanism in which you will come to know that there is formation of carbocation. Are you done with this, both of you?
Are done.
Okay. So see, I'm going to start the mechanism. I will zoom it and then I will write a step by step and then zoom out. Okay. So when we are going for mechanism, mechanism is very important. Okay. Mechanism we are going to do. Now see, in the first step, that step one, you should also know the step one is what is going to happen in a step one, a step two, a step three. So in a step one, protonation will take place. Just wait a minute. Yes, that's it. Protonation of alkene, of protonation of alkene to form carbocation, form carbocation by electrophilic attack of by electrophilic attack of H3O positive. So in the first step, there will be protonation. Protonation of alkene will take place. Let's take this alkene. Let's take this alkene. C double bond C, and this will be the scenario. So first of all, acid is present in H2O. So there will be H3O, formation of H3O positive will take place. So first I'm going to show that reaction. Basically, H2O is H2O is there and acid is present in H2O. You know that oxygen has lone pair. So it will basically attack on H plus and you will get H3O positive, which has a name hydronium ion, which has a name hydronium ion. Now this alkene will come into play, C double bond C. And H3O positive, I'm going to write like this, oxygen, hydrogen, hydrogen. One of its lone pair has been used, so only one lone pair is there and positive is there. Now what will happen? Since there is a positive charge, so this alkene act as nucleophile. So this alkene will be doing what? First of all, oxygen, there is positive charge on oxygen, that means highly unstable. So what will this oxygen do? It will take electron from hydrogen to stabilize itself, So when it will take it, O becomes neutral and it will be eliminated or removed in the form of water. Now this hydrogen is in H plus. So this alkene, which will be acting as nucleophile, basically attack on this hydrogen. Okay, so what will happen? There will be formation of carbocation. Basically, this carbon will be taking this carbon's electron, so there will be negative charge, and that negative charge will satisfy this hydrogen. So it becomes like this, and this will be formation of carbocation. Are you getting my point, both of you? So in the first step, formation of carbocation will take place. Is that clear? Mom, am I audible?
Yes.
Austin? Okay. So in the first step, we saw that formation of carbocation takes place. Now, come to the next step, step 2. What happens? In step 2, nucleophilic attack of water on carbocation. Nucleophilic attack on carbocation. On carbocation. That means we are going to take this carbocation, and since this carbocation is in water, right? Hydrogen is there and C positive, and this will be there. So it is present in water. So it will be like this. Now this water is a nucleophile. So this will be attacking directly on carbon to satisfy carbon. So what will happen here? The left part will be as it is. The left part will be as it is. And this carbon is now satisfied by oxygen. Oxygen already has two bonds, so now oxygen will have positive charge because it donated one electron. It donated one electron. After this comes the step 3. After this we have step 3, in which you will see that deprotonation to form an alcohol will take place. Deprotonation to form an alcohol. Deprotonation to form an alcohol. That means this one, I'm again going to use this. You can see this is the scenario, hydrogen is there. And this is the scenario. Oh, H2 I'm going to write and H plus. I should not write this. I should write this. Hydrogen and hydrogen. I told you that oxygen, positive charge on oxygen is highly unstable. So what will happen? This oxygen will take electron. This oxygen will take electron from hydrogen. And it becomes, now there is hydrogen. Now it becomes alcohol here. And H plus will be eliminated. The H plus that you used in the first step will be eliminated in the last step. So again, I'm going to explain this step by step. Mechanism is very important. They can ask you the mechanism and there will be a question on that mechanism. So it will be around 3 or 4 marks. First, protonation of alkene, and you are going to write in the same way that I wrote here. First, step 1, what you are going to do, you need to make a sentence and write it, then show the reaction. Protonation of alkene. What you are going to do, very simple. Protonation of alkene to form carbocation by electrophilic attack of H3O positive. So first I prepared H3O positive. When water in water H plus is present, so it becomes H3O positive. Now H3O positive is unstable because oxygen is more electron negative element. So positive charge is unstable. So H plus will be released from here, which will be attacked by alkene, and then your carbocation form. After carbocation formation, nucleophilic attack on carbocation. Nucleophilic attack on carbocation will take place. Nucleophilic attack of carbocation, it will be better. Nucleophilic attack of water on carbocation takes place. Okay. So you can see oxygen has positive charge, and at end deprotonation, that means you are going to remove water. H plus deprotonation, that means removal of H plus will take place, and you will get your alcohol here. Is that clear? Please do write it. And since I told you so many times that we are having, whenever in mechanism you have, what do we say? Formation of carbocation, rearrange if possible. I will give some question on that. Yeah, let me know when you're done with this. Are you done with this?
Done.
Very good. Now see, Austin, you are also done, right? Austin, you can send the chat like for everyone. Then I will be able to see. Okay. Okay, so this is the preparation. So I'm going to give some important question in this. Okay. So first question that I'm going to give you is this: H2O in the presence of H plus. And the second question I'm going to give you. See, I told you so many times, whenever this is a note point, if carbocation forms, then rearrange if possible. Then rearrange if possible. So I hope you are understanding this and you have you know this concept already explained, but if you face any problem, I will explain it again. Tell me the product. Major product always. You can tell me all the possible things. Yeah, don't take much time because it's not that much tough. I hope you will understand. Only you need to add H plus and OH minus with the possible position. Austin, are you there? You are not responding today. Please mute it. It's you can chat, reply in chat. So you replied something. I'm going to say pentane 3 all. Okay. Methyl pentane 3 all. Okay. So I'm going to explain this. Humam, see, you have this situation. This is the reaction. You have H plus and OH minus. Now see what will happen. This H plus can either go into this and OH minus to this, or either it can happen like OH minus can go to this and OH minus, H plus can go to this, right? So both the product I'm going to write. First OH minus I'm going to write like this and H is there. H is there. And if I'm going to show you with this, I can write this OH here and H here. Okay. So which one will be the major product? This one will be the major product. Are you getting my point? Yes or no?
Yes, sir.
Now see, by the mechanism, you should not go like this. You should go like this. Let me explain this. This is the scenario, right? So what you should do if you're going to react with water in the presence of acid, either positive charge will come here or either positive charge will come here. So I'm going to write positive charge here. This H plus, that means it attacked here. Okay. Or either the positive charge will be coming here. That means this H plus is going to attack on this already attacked, right? So only you need to uh, uh, focus on the carbocation. Now, which one is more stable, this or this? See, this carbocation is stabilized by 2 ethyl group, and this carbocation is stabilized by 1 methyl and 1 propyl group. And you know that this, what do we say, inductive effect, plus I effect is distance dependent. So this carbon will get some support from this carbon, but will not get much support from this because distance increases. So this carbocation is more stable. That's why you can see, you can do like this. That's why OH will come here. Is that clear?
Yes.
Okay, just wait a minute. Okay, for the next one, I'm going to show you. The next one is very important. Okay, so either positive charge can come here and positive charge can come here. If positive charge you are going to make it here, hydrogen will be added on the next. So I'm going to show you. If positive charge, if I'm going to make it here, it will be like this. Or positive charge, if I'm going to make it here, the hydrogen is here now. Now, which one is more stable, this one or this one? What do you think? This one is more stable, right? So what you need to do is very simple. You need to focus on this carbocation. Carbocation formation takes place, then you are going to shift. If it will shift towards more stability, like from this carbocation to this carbocation and this carbocation to this carbocation, directly I'm going to take this, because if you are going to do hydride shift, what is hydride shift? So there is a hydrogen which will take carbon's electrons, so there will be development of positive charge, and this hydrogen, which is now in H negative because it took electron from carbon, will be attacking on this, so it becomes neutral. And you can see positive charge is here, so the stable now the product will be OH minus will be attacking here, because this carbocation is more stable than this and than this. What is this rearrangement is basically whenever you are having carbocation formation, you need to check the stability of carbocation. And if you are going to do some hydride shift or methyl shift and carbocation becomes more stable, then you have to do it. Like this is 2 degree, this is also 2 degree. But if you are going to move to this direction, if you are going to move to this direction, it becomes 1 degree less stable, you cannot move. But if you are going to move to this direction in this, so 2 degree to 3 degree, this is your more stable. So if from here I'm going to remove H negative, H negative means what? There will be development of positive charge. That means the carbocation shifted to this tertiary, it becomes. Now OH minus is waiting for this scenario and then attacked on this, and you got this. So the name will be Humam and Austin. 2-methyl pentane 2-ol, not 3-ol. Got it, Austin? This is how shifting takes place. I'll give you one more question. First, write it. Let me do something like this. Let me know when you are done with this. Mhm. Mhm, mhm, mhm. Mm. Are you done with this, both of you?
Yes, sir.
Okay. So the next question I'm going to give you, it is a very good question. Let's see whether you are able to solve it or not. Okay, let's say this is your H2O in the presence of H plus. And another one that I'm going to give you is this H2 in the presence of H plus. Any answer for this one? Okay, see, I'm going to explain. See, positive carbocation can form here or can form here. It depends upon you which you are going to take. So carbocation, if it is going to form here, it will be 1 degree and this will be tertiary. So I'll prefer the one which is tertiary because tertiary carbocation is more stable. Then OH minus will come into play and it will attack here and you will be getting this as a main product. And if you are going to shift here, there is no possibility of shift because as you can see, this is tertiary. If you want to move left side, it becomes secondary. If you want to move right side, it becomes secondary. And for shifting, for rearrangement, it is important to know that it will go in higher stability, never goes in lower stability. Is that clear? Is that clear, both of you?
Yes, sir.
Now see, for the second one, in the second one, carbocation can form here and carbocation can form here. Let me, Huma, which one, which carbocation you want to form? First position or second? What do you think? Huma, first or second? Second. Second, why? Because it is secondary. Because it is secondary, simple. If you are going to form at the first, it will be primary. So secondary carbocation is more stable. Now go for rearrangement. If you are going on the right hand side, it is 1 degree. If you are going bottom, it becomes 3 degree. So there will be hydride shift. There will be hydride shift. Hydride shift means what? This hydrogen will take carbon's electron. When it will take carbon's electron, so what will happen? There will be carbon will have positive charge, and then you can see hydrogen will be shifted here. Hydrogen we generally don't show, and then OH minus will come into play and it will attack on tertiary, and you will be getting this. And you will be getting this one. Is that clear?
Yes.
Please do write it. Yeah, do write it. After that, we are going to do this by hydroboration oxidation. Both of you done with this?
Done.
Okay. Just wait a minute. You can take a screenshot of this. This is a roadmap reaction, carboxylic acid. All the reactions of carboxylic acid. Are you done taking a screenshot?
Yes.
Okay, see. The next preparation from alkene is your. I'm going to zoom in and then show you, then zoom out. By hydroboration oxidation. What is this? Very simple it is. First of all, you need to remember one thing. By this method, you are going to apply anti-Markovnikov. Anti-Markovnikov, if you remember, opposite of Markovnikov. In this, you are going to apply anti-Markovnikov. Okay. Now see what will happen if you are going to react an alkene in the presence of B2H6. Then basically you are going to react with B2H6 in the presence of H2O and hydrogen peroxide, 3 moles of peroxide, and basic medium it should be. So what will happen here? Very simple. From this reagent, you will be getting two things, H plus and OH minus. Now what will happen? Basically, this OH minus will go to that carbon which has greater number of hydrogen. Negative part will go to that carbon which has greater number of hydrogen, and positive to that carbon which has lesser number of hydrogen. So you will be getting CH3, CH2, and it becomes CH2H. It is just like anti-Markovnikov. Are you getting my point? So opposite of Markovnikov's it will be okay. And if you are going to see in NCRT, see how the reaction will be taking place in NCRT. Step by step, I'm going to explain. This is your CH3CH double bond CH2. And if you are going to react this B2H6, I'm going to write B2H6 as HBH2 whole twice. That means BH3, HBH2 means BH3 whole twice. It becomes B2H6. So when it is going to, the reaction will be taking place, this bond will be broken. First, this bond will be broken and this bond will be broken. Now, what will happen? This H, basically, this H will be going to the lesser number of hydrogen. Basically, there will be positive, there will be negative. You can treat it like this. And this BH will be going to this, will be going to this. Now, what will happen? What we will get, that is important. And you can see you will get CH3 and this becomes CH2. And here it becomes CH2 and then BH2, BH2, and then BH2. BH2, I'm going to write BHH, something like this. Again, you are going to react this, this new product with CH3, CH double bond CH2. Again, you are going to react with this. Now, what will happen? This bond will be broken and this bond will be broken. Hydrogen will be going to that carbon which has lesser number of hydrogen and BH will be going to that carbon which has greater number of hydrogen. Try to understand the concept. First, I'm going to write this. If I'm going to write this, this will be CH3, CH and CH2. This CH will be added with this black hydrogen, it becomes CH2. And this CH2 is attacked by BH. BH, that means B or H, I'm going to write it like this. And B is connected with CH2, CH2, CH3. So I can write CH2, CH2, CH3. Yes or no? Is there any problem? Is there any problem? After this, again you are going to, again you are, since one hydrogen more left here, again you are going to react this with CH3, CH double bond CH2. Now what will happen? Very simple. This bond will be broken and this bond will be broken. The hydrogen will be directly going to the carbon having less number of hydrogen and B will be attacking on this. So first I'm going to write this. Can I write this as this? Try to understand the point. Boron is in between. On the left hand side, we have CH2, CH2 and CH3. On the bottom, we have CH2, CH2 and CH3. And then you can see this CH2 is attacked by this boron. So there is CH2 and before this CH is there and then CH3 is there. But this CH3 is attacked by this boron hydrogen. So it will be like this. So I can write directly B CH2, CH2, CH3 whole thrice because it is coming 3 times. Yes or no? And after getting this, what you need to do, you are going to hydrolyze it in the presence of peroxide, 3 moles of peroxide and alkaline medium base. Then you will be directly getting, remove this B and add OH there. Add OH there. At the place of CH2, add OH and it will be of 3 moles. Plus there will be a byproduct, boric acid, BOH whole thrice. In this, you will get boric acid as well as a byproduct. So this step is given in NCRT actually. Okay, you can directly apply this anti-Marconi को break the double bond and you will get this. I think it's clear to both of you. Please write it carefully. Let me know when you're done with this. So if I'm going to give you a question like this, let's say this is the scenario, B2H6 in the presence of, followed by hydrolysis, and H2O2 in the presence of base. So what will be the name of the product?
मम्मी नाश्ता नहीं करें, खाना नहीं खाएंगे।
So very simple it is. There is two hydrogen. From here H plus and OH minus will come into play. This OH minus will be attacking this, H plus will be attacking this. So you will be getting 3 moles of this. Oh, just wait a minute. You will be getting 3 moles of this along with boric acid. That means we can write H3BO3. Is that clear? It's so easy. Is that clear, both of you?
Yes, sir.
Okay. Moving to the next, which is very important. And this reaction already you have studied. So the second reaction is from carbonyl compound. From carbonyl compound. Now see, from carbonyl compound, if you have studied and if you have in mind the chemical reaction of aldehyde and ketones, and carboxylic acid, then this reaction is repeated. So in this, we are going to study the first one is about your by reduction of aldehydes and ketones. Aldehydes and ketones. So can anyone tell me, if you are going to reduce aldehyde, what type of alcohol you will get? Both of you, I'm asking from both of you. What type of alcohol you will get if you are going to reduce aldehyde? So first of all, you should have a reducing agent, and then if you are going to reduce aldehyde, you will get 1 degree alcohol. If you are going to reduce ketones, you will get secondary alcohol, if you remember. So here what I'm going to do, aldehyde is there, RCHO, and you are going to react this H2 in the presence of palladium. So this will be reduced directly into 1 degree alcohol, RCH2OH. If you remember, I explained you in this way, RC double bond OH is there. When it is going to react with this, what will happen? This bond will be broken. Hydrogen will be added here. Hydrogen will be added here. Again, another bond will be broken. Hydrogen will be added here. Hydrogen will be added. Oh, just wait a minute. I just made this mistake. Okay, one bond broken, so it becomes this one. Okay. So basically what will happen now, this down part, if you're going to see, it becomes RCH2 and OH up part. So it will be converted into primary alcohol. Now, if you have ketone like RCO, R dash, and you are going to use sodium boron hydride, NaBH4, which is a reducing agent, and so it will be converted into RCHOH, R dash. How does this reaction takes place? So very simple it is. You can explain this with the help of this carbonyl group, RC double bond OR dash is there. If you are going to use this reagent, what will happen? This one bond will be broken between carbon and oxygen, and this will what it forms, RCH OH R dash. Are you getting my point? This NaBH4 is a very good reducing agent. It will reduce only aldehyde and ketones into alcohol, not ester or any other carbonyl group. It will reduce only aldehyde and ester on aldehyde and ketone, not any other group, not any other carbonyl compound. Please keep it in mind. Your assessment test is activated. I hope you are going to attempt that. Let me know when you are done with this.
Yeah.
Very good. Now, this has a power sodium boron hydride only to reduce aldehyde ketones, no sister or not any other. So if I'm going to give you this reaction, 2 moles of NaBH4 I took. Tell me the product. See, this is your ketone and this is your aldehyde. So basically it's very easy. It can be reduced. This bond will be broken. Hydrogen will be added here. Hydrogen will be added here. That means secondary alcohol it will easily give you OH. This will be broken. Hydrogen will be added here. Hydrogen will be added here. So it becomes CH2OH. And the rest part will be as it is because it is not that much powerful to reduce this ester. Is that clear?
Yes.
Okay. Can I change the slide?
Yes.
Okay. The next is carbonyl group. By reduction of carboxylic acid and esters and esters. How you are going to reduce carboxylic acid and ester to alcohols. So if you are going to use mild reducing agent on carboxylic acid, first it will convert into aldehyde and then again you have to reuse to convert into alcohol. But if you are going to use a strong reducing agent like lithium aluminum hydride followed by hydrolysis. In the second step, you need to follow the hydrolysis. It will be directly converted into alcohol, 1 degree alcohol. See, if you are going to use mild oxidizing agent, mild oxidizing agent on 1 degree alcohol, you will be getting aldehyde. Then again, you have to reuse that mild oxidizing agent to get carboxylic acid. In the same way, 1 degree alcohol converted into aldehyde, then carboxylic acid. In the same way, a reducing agent when you are going to use a strong reducing agent, carboxylic acid will be converted into 1 degree alcohol, 1 degree alcohol. And mild reducing agent, it will give aldehyde and then 1 degree alcohol. Is that clear? And generally we don't prefer this LiAlH4 only because it is quite expensive. So we are going to use another alternate method First, we are going to use this carboxylic acid with alcohol, R-OH, in the presence of acid. In the presence of acid. So what will happen here? This will be giving this is your plus, this is your minus, this is your plus, this is your minus. So this will be converted into ester directly, RCOOR-, and this forms H2O. It will be in the solution. Okay. After this, you are going to use H2 in the presence of catalyst. H2 in the presence of catalyst, and then it will be converted into RCH2OH. And the alcohol that you used here will also be eliminated. The reaction here took place like this: RC double bond OH, RC double OR dash. I'm going to expand this. I'll show you. RC double bond O, OR dash. So basically what will happen by the H2 in the presence of catalyst, this will be broken, hydrogen will be added here, hydrogen will be added here. Okay. And then what will happen? This will also be broken, hydrogen will be added here, hydrogen will be added here. This is gone, that is H2. And then this will be broken. Oh, wait a minute. I did some mistake, just wait a minute. Just wait a minute. I should write it up. This is RC double bond O, OR dash. So first I'm going to break this bond, add hydrogen here, hydrogen here. So what it becomes, you can see this becomes R-OH, the one which you used in the first step. And then you are going to break this hydrogen, hydrogen. So what it becomes, RCH2OH. Are you getting my point? So from ester, how you can get alcohol is very simple. You are going to react with hydrogen in the presence of catalyst, you will get alcohol. I hope this is clear to both of you.